Good afternoon, everyone.
Good afternoon.
Oh, that was actually good. We're going to try it one more time because I thought I'd get no responses. Good afternoon, everyone. All right. Just want to make sure everyone's awake and with me. It's been a long day of a lot of good information, right? But sometimes the eyes can glaze over. Okay. So as mentioned, I'm going to talk today about aqueous pigment inks and some of the technology challenges for the growth areas and some of the knobs that we can turn to help find solutions for those. There we go. All right, so DuPont, who I work for, right, has made aqueous inks for over 25 years for a broad variety of applications. You can see all the key ones that we focus on here. For today's talk, I'm going to focus primarily on textile and packaging, right, which are two areas that are continuing to grow and where we expect to see continued future relevance for inkjet. So let's start with textiles, right? What's shaping where the textile industry is going? Well, here are some of the trends shaping the fashion industry, which I don't think is news to anyone, right? So shorter seasons, so more of this fast fashion, faster turnaround. Mobile commerce, right? So consumers now are used to being able to order something, right? Stores want to manage their inventory, but your customers still want it to show up in a very quick time frame. Virtual and augmented reality. So if you've been keeping up with this, right, there are more and more innovations where you or I could now, on our app or in a store, kind of virtually try on and fit a garment that may or may not exist at that point, at some point in the future, order it, and still expect to receive it in a very timely fashion, right? And it could potentially be custom made for us. And obviously sustainability. So consumers are continuing to drive brands to make sure that they are using the most sustainable processes. There's a lot of attention to how we're treating the environment. And so all of those things, in terms of that just-in-time production and desire for greener processes, really drive a great fit for digital printing, right? In particular, aqueous inks can have some benefits there. And just to talk about that a little better, for those that paid attention, right, last year Amazon was granted a patent that talked about kind of this automated on-demand cut and sew type application. And so I don't want to focus on the entire patent. The one thing that I do want to focus on is a section here where it talks about the print engine. So clothing is ordered, right, in this concept. And here you have a printer where you take plain rolls of fabric, and so you're printing the garment and the desired pattern right there. Right, and so that dress and that shirt may actually be completely different designs, patterns, or colors. It all then gets, cut out and sewn in an automated process, and the garment is made. And so, with innovations like this, as we go further and further into the future, what are the types of inks that could really lend itself to this sort of design? In particular, if you have some of these things being located in more of the industrialized areas where there's a lot of sensitivity about effluent waste streams and sustainability concerns. So if you look at inks that are commonly used in digital printing for textiles, and so DuPont makes all of these types of ink chemistries. Let's start at the top. You can see with reactive and acid, right? These are processes that require a lot of steaming, right? So high energy processes. Heavy washing, so you have a lot of chemicals going into your effluent stream. You get to direct disperse. The story's a little better. You just have to do heat fixing on a drum, but there's usually a washing step required there. And then the last two, if you look at sublimation, right, you kind of have the ideal case there where you just have to have that heat transfer process. There's no additional post-processing steps, but that only works on certain types of fabrics. Right, you can't print on anything. Whereas if you come down to pigment as a solution, you now have just the heat fixing step. While some people may choose to wash it, you typically do not. But you can print on any sort of substrate that you desire in that case, right? And so all of that being said, as we look at where things are going, right, aqueous pigment gives you the benefit of not having the high capital costs or energy expenses. It gives you the better environmental impact, right, with no wastewater, less hazardous chemicals, and you have the flexibility to print across all fabrics. And so this is really something that I think would fit well into these concepts of the future about how clothing may be made, which is very different than the way it's made today. So let's take a moment and look at what's going on in packaging. So if we look at the packaging market, right, similar sorts of trends in that you've got customization and artisan brands, right? So these are, again, around smaller lots, smaller runs, less overall inventory. So you don't need to do big production cycles, shorter turnaround expectations. So once again, you have customers ordering things on their phone that you may not necessarily have in inventory today, and they want it to be produced and delivered to them in a very timely fashion. Functionality, right? So there's lots of desire now with the ability to print things on packages where you can track them. And again, sustainability in a similar sense, right? Are you working with things that are recyclable? Are you taking good care of the environment? Packaging often comes in contact with food, et cetera. Are you using materials that are considered less hazard or have lower hazard profiles? And so once again, these shorter runs, these desires for greener processes really lends itself well to digital printing and in particular aqueous ink chemistries. So if we dig a little bit deeper into the packaging application, the way we think about it in DuPont, we tend to break it up into 4 categories, which I think are fairly common, even though people may give them slightly different names. So corrugated, in which you're printing on coated or uncoated papers, right? Folding carton, primarily coated papers, almost exclusively. Tag and label, in which you're looking at mixed media, right? So you can go anywhere from what we would call plain papers to films. And then flexible film, which is, you know, all types of different films, with the added requirement of some level of food compliance, whether it's indirect or direct, right? And so that also increases the complexity. And so as a result, as you move from what's going to be to your right on this chart, right, you can see that the technical complexity for aqueous digital inks increases as you head towards flexible film with the additional added piece of food compliance. And so why is that? If we think about the substrates that you're printing on, right? If we think about kind of printing that we've been doing for a long time on various uncoated or plain or inkjet coated papers and or textiles, right? You have substrates where you are printing your aqueous liquid ink and the liquid has somewhere to go, right? When you move now into things like packaging or areas that have heavily coated papers, you're talking about either low porosity or substrates with no porosity at all. And now that fluid has nowhere to go. You have to remove it all in a different way. And also these substrates tend to be fairly hydrophobic. So great, we have all these different substrates to print on. You know, aren't people printing on aqueous inks on plastic films today? So why is inkjet so much more complicated? Well, if we take a quick look at what's in an ink, right? And this is for instance, right? This doesn't represent every flexo ink or every inkjet ink. It's just an example. But you can see with aqueous flexo inks that may be used today in more traditional analog processing on things like flexible film, your solids, which are typically your pigment, dispersion, and your binder, can make up to 50% of that particular composition with viscosities that can go into the hundreds of centipoise. For aqueous inkjet, your solids are typically no more than about 15% of your composition with a much lower centipoise, right? So then when you look at all of the other components that are in the ink, right? So your co-solvents, your water, your surfactants, and your additives. The other key thing is to pay attention to the yellow slice on the pie chart, right? In aqueous flexo inks, you have a very low level of humectant, whereas in aqueous pigment inks for inkjet, we tend to have a very high level of humectant, and the obvious reason for that is because as you're printing, you don't want your ink to be so fast drying that it's drying on the print head nozzle, right? Because then you're going to have a terrible printing performance. And so typically you put a lot of humectant in there in order to have good printing, but now on these non-porous substrates, you need to be able to remove the water, and the whole point of a humectant is to retard drying, right? So you have that challenge that you then need to meet when you're looking at these non-porous substrates. So formulating aqueous inks for these applications is a balancing act, right? You're constantly looking at, and again, this is not an all-inclusive list, it's just a few of the key things I wanted to highlight, right? You're looking at really balancing your jetting reliability, your print quality, compatibility with your overall system. And your different components of your ink, right, will impact each of these categories in a different way. So if we look for a moment at your binder, which is essentially your polymer in your formulation, the more binder you have, in most cases, the better your print durability will be. And so that's a great thing, and we all love to load all the polymer in the world into every possible ink, except, of course, when you get to a certain point, it starts to mess with your jetting reliability, right? And you have a hard time jetting the ink. And so you're always doing this dance. That's not my clicker. There we go. Right, to basically balance these various categories, right? Because your binder can also have a positive or negative impact on your image quality. In some cases, it can affect the color in a bad way. In other cases, with the use of pretreatments, it might do better. And so what I'm going to do on the next couple of charts is just unpack a little bit a couple of these performance categories. And again, right, the knobs you can turn to try to help balance, to deal with this balancing act. So let's talk first about print quality. And in this category, I'm kind of lumping together your image quality and your durability for the print image. So again, an ink is made of many things. These are just a few of the ones I'm highlighting. But if you think about your color, your binder, which is your polymer, and your surfactant, let's start with color, right? So higher color, better thing, right? Usually customers want higher color strength, better OD. And a logical way to think about that is, well, load as much pigment as you possibly can into your ink, and that is likely to give you some of the best color you can achieve. Well, sometimes the interesting dance you get to play is if you look at this orange line on this chart, right? This happens to be a magenta ink. This actually has the highest pigment loading for this sample, so good color strength. But if you see where it sits on this AB axis, it actually starts to shift over into the reddish sort of area. And so the issue with that becomes you didn't get a nice pure magenta. And so it turned out that actually stepping back on the pigment loading was a better thing for this particular ink formulation, because it gave you a much cleaner magenta that was repeatable despite the amount of print density that you had. But at the end of the day, that was actually the thing that made the color look the best, not just aiming for maximizing the amount of pigment, right? So again, it's always this balancing act and understanding what affects the performance you're looking at. Similarly with gamut, right? So this is just a little image of a gamut. This happens again to be a magenta. But the one comment I wanted to pair is, you have a certain gamut volume, and you may get requests where customers say, well, I want, more in this sort of magenta region or reddish region, less in the blue. You may find that, okay, maybe you need to mix in another pigment or something else in order to achieve that. And so you'd think, well, we've balanced this formulation just right. We have the ideal dot spread, right? It's pretty durable. Everything looks great. All we're going to do is add a little bit of a different pigment. Should be fine. Well, you may find that once you do that, you actually affect your dot spread, which may require you to do something else around your surfactants. But again, you had the ideal dot spread, right? So nobody wants you to touch that. They just want you to fix the color, just that one thing, right? So again, it's just a little bit about the dance and the challenge that you can have. And then finally, here, just wanted to talk about durability. So what you're looking at here is a sample of our white ink on a film, right? And so basically, you can see, right, this was just an evolution of some of the work that we've done, but you can achieve a good optical density with a white pigment ink on film. But then you have the challenges, right? Ultimately, people that are looking at pigment inks on film ideally don't want to have to overprint it. And so you can play with some of the knobs, like your binder selections, to be able to improve your overall durability so that you don't smudge or scratch it as easily. Next, just a few words quickly about pretreatment. So I think the great thing about working for a company that makes inks is sometimes people only want to talk about the inks, and the thing that you learn over time is that really you're dealing with printing systems, right? And so system solutions are often a very effective way to go. And so in this particular case, so pretreatments, again, you've got your polymers, salts, functional additives. There are other things in there, but those are just a few of the ones I'll highlight. And I think as we saw earlier, I forget whose presentation it was where they showed a sample of this, right? Again, this is some of our ink samples from the lab on film, right? And this is printed, whoops, there we go. This is printed on, I believe this is a PET film, right? You get a lot of running, but then if you apply a pretreatment, and in this case, it's a pretreatment that we're designing that's actually matched with the ink that's being used, you can do a lot in terms of your overall image quality, sharpness, and also durability, like the white ink you saw on the previous chart. Similarly, in textile applications, pretreatment can have a massive effect. And so these 3 samples here are all the same ink, the same fabric printed under the exact same conditions. Really, the only difference is the particular pretreatment formulations that were used. And you can see very clearly, right, the clarity and the sharpness of the line that's printed. And so if you think about that in a larger image, if you were to take a step back from the magnification, it's not just going to affect your line acuity and how sharp your image is, but it also could give you a brighter color, or what appears to be a stronger color strength, because now you've got more of the ink sitting up on the fabric. And of course, there's print reliability. So this is the last sort of performance component that I'll talk about. And because apparently Czar is breaking the laws of physics there, with the Onosorgi number, right, and they're printing outside of this printable fluid zone, I won't touch that. But the idea is that, physics defined for us at one point sort of the range where with different fluids you can get a good drop breakup and sort of form ideal drops. All I want to talk about is how the things that you put in your ink affect your ability to form good drops. And so in this case, I'm highlighting your dispersion, or your particle size of your colorant in your dispersion, the polymer, and then your surfactants and humectants. And so what this chart really shows with these different inks is you can have a situation where you eject a drop, you form a tail, and the tail breaks off and the 2 drops never catch up, right? So that's going to have a negative impact on your image quality. You can form an ideal drop right off the bat, or you can form a tail that almost gives you a satellite, but it actually is able to catch up with the drop before it hits the surface. And the point here is that how this behaves can really be tuned in some sense by your dispersion or particle size, but also even by the polymers that you're using. So you could have a situation in which you have something that breaks up into a less than ideal drop, but because of the components that are in the ink, they're actually able to catch up and form an ideal drop before hitting the substrate. The only other thing I wanted to say about this, and it's a little bit of a commercial, is ink does not solve it all, even though we would love to take credit for all of it. And so the other thing is you can create an ink that gives you a pretty good drop, and you actually are able to create a perfect drop if you spend a little bit of time on the waveform. So that's just my commercial for system solutions, right? Because at the end of the day, the waveform is also a powerful tool. And the final comment I'll make about this is just, again, another example of how your polymer selection can have a big impact, right? So this is, again, this happens to be a magenta ink. I guess I have a theme here. Polymer A, right? You can see you've got significant wetting on the nozzle plate. And just by looking at a different configuration, we were able to maintain the properties, but essentially you have a very clean nozzle plate with no wetting at all. So I'm not going to talk about this in depth, but I do think it's important to note, right, that I think, you have a lot of NGOs out there like Oikotex and people that certify the inks. There are all of the sustainability concerns that I mentioned earlier, right? People are concerned about the materials that are going into their formulations. So this is really just a thing to say that while you're solving this balancing act, right, sometimes your toolboxes can become very constricted because you have to be very aware of what you're using. And this is particularly true when you move into the space around packaging printing and food compliance, because essentially what you're looking at there is, everything that you use has to be approved, say, per the Swiss ordinance or one of those requirements. So hopefully you caught on to the theme as I went through my earlier charts that I kept mentioning the binder and the polymer and the different impacts it could have. And the reason is because when we talk about how are aqueous pigment inks really going to have breakthroughs and really be appropriate for the next generation of applications, a key knob is going to be your polymers, right? And so with strong polymer competency, good polymer selections, in our case, we do have that internally. So if it's not something we can source, we can often make new materials that will do what we need them to do. It's important to being able to break some of these challenges that you have. And so in this case, if you take a look, right, you can, I don't keep clicking the wrong thing. There we go. If you take a look, right, you can design polymers that can give you thermal functionality, right? So once you heat them, they change binary systems. So essentially, it has one set of properties in the print head when you print, and then when it hits your substrate, the properties change. Reactive groups, I think people are very familiar with general polymers. I think the other thing that's really interesting with polymers is that there are more and more sources as polymer innovation moves forward of the ability to bio-based or bio-source polymers, and also a lot more work going on in how some polymers can be biodegraded. And so I think as all of those things evolve around different types of polymer chemistries, we're really going to be able to achieve more in this space. And as a very quick example of just the general power of polymers and how you design them, right, this is a cartoon of basically a dispersed pigment, right? So you can see the dispersants all around the pigment, and you can cross-link it. And in reality, what that does is really help widen your formulation box, right, to help you with this balancing act. And so at the end of the day, as you start to play with the vehicle in this first photo, you can see that you get to a point where you destabilize your dispersion and all your pigment settles out. But in the second example, with the cross-link dispersion, we were able to do a lot more in terms of the various changes we could make to the vehicle to help balance the performance properties. And with that, I'm at the end of my talk. So once again, I think aqueous pigment inks are well positioned to help address the future demands. And again, the formulation knobs there with the pigments, the various polymers give you a lot of flexibility. You can really tune the performance a lot, and you can come up with options that give you good sustainability. Polymer competencies are key. I'll keep banging that drum. And I think that, again, the commercial for the solution of a system, right, those are continuing to evolve. I think ideally you have customers that will say, nope, we want the ink to do absolutely everything, but there are ways where you can look at, say, with pretreatments, can you either selectively place pretreatment so that you're not having to flood coat your entire substrate. You also have options, as I mentioned, with potentially some binary systems where theoretically the ink is doing everything, but it may be because you have a two-component system. So there are lots of innovations coming ahead, and I think it's a fun area to work in, and I'd love to see what happens as we move into these new spaces. So thank you for your attention, and happy to take any questions.